Well, hello everyone, and welcome to an afternoon with Audrey, with Math by Audrey. Well, I'm your lovely host, Audrey. Anyway, so we're going to be looking at ratios, proportions, and percents, just like you will see normally in most standardized algebra courses. Also, you can see in your GED or high school equivalency tests, the ASVAB, the Accuplacer, the TEAS test, and the HESI test. So when we're looking at percents, we always want to think of a ratio. It's always the part over the whole. So if we take a look at number one, a ratio of red pens to blue pens in a box is 3 to 5. That's how you read what the colon is, okay? 3 to 5. If there were 64 pens altogether, how many are red? Well, first off, we need to take a look at the ratio they're giving us. So they're giving us red to blue. And you can see ratios represented one of three ways. One, you can actually see with the word to, another one with the colon, but the most popular one, you see it as a fraction. So we're saying that the ratio of red pens to blue pens is 3 to 5. That means there's 3 out of 8 total red pens, and then there is 5 out of 8 total blue pens. Okay, so since we want to figure out how many are red, and they said there is a total of 64 pens altogether, that means we're not looking at a ratio of red to blue. We're looking at a ratio of red to total. Okay, we're looking at that ratio of red to total. So that means if we're looking at what they're giving us, there is 3 out of 8 pens that are red. Now we're going to compare it to another situation where the total number of pens is 64. This right here, when you have two ratios equal to each other, that's called a proportion. So that's what's going on right here. So you have a part over the whole situation for one. Then we're going to compare it to a part of a whole situation for another. But this time we have to figure out how many of those pens are red. So we could do this one of two ways. One way is, since we don't know what's here, some people like to put a box, or some teachers, like especially when you get into algebra, they like to put an X. And what they do is when you have two ratios equal to each other, you're going to cross multiply. So if I cross multiply, I have 8 times my unknown. So I'm going to put it over here. So that gives me 8x, or 8 box. Then I need to multiply the 3 to the 64. So 3 times 4 gives me 12, carry the 1. And then 3 times 6 gives me 18, plus that 1 gives me 19. So that means 64 times 3 gives me 192. So now I want to know what my x equals. So I could divide both sides by 8. So I can isolate my variable. 8 divided by 8 gives me 1x, or just x. And then I need to take a look. All right, dividing 192 by 8. How many 8s can go into 19? Well, we have 2 of them. Okay, so that will give me my 16. So 19 minus 16 will give me 3. Now I have 32. So how many 8s can go into 32, which will be 4. So that means how many, if I had a total number of 64 pens, how many of them are going to be red based off of this ratio? It's going to be 24 red pens. And like I said, this is one way of doing it. Another way is to look at the two ratios themselves. Okay, so this is a second way. So another way, I want to look at 8 going into 64. How can I go change 8 to a 64? Well, that's multiplied by 8. So what I could do is take this 3 and do exactly the same thing that happened in the denominators. I can multiply this by 8. So that means 3 times 8 gives me 24. So I'm using the patterns to help figure out what would give me my unknown value for that numerator. All right. So when it comes to ratios, it's basically your part over the whole, what you're looking for over the total amount. Then when it comes to a proportion, that's when you have two ratios that are equivalent to each other. And you can either do cross multiplication or figure out its pattern. Okay, or you could have just done 64 divided by 8 gives me 8, and then you have to say what divided by 3 will give me the 8. You could have done it that way as well. All right. So for number 2, a car drives 156 miles on 6 gallons of gas. At the same rate, how far it travels on 15 gallons? So how do I know I'm going to be setting up a proportion? Is exactly this. First, they talk about miles and they compare it to gallons of gas. So if I'm comparing two things, that means I should be setting myself up a ratio, which will give me a proportion. So that means my numerator, since that's the first thing that comes up, could be the miles. And my denominator could be the gallons. So my first ratio is going to be the first information that they give us. So my miles is 156, and that's on 6 gallons of gas. So what they want us to find, which is the question, how far? Now, how far, that's going to be dealing with miles. So this is going to be my unknown. That you can travel for 15 gallons. All right. So now from here, we have a proportion. We want to know what this x is. So unlike the last time, we can't just simply say, all right, 6 times what will give me 15? Because 15 is not a factor of 6 or is one of those numbers of 6. But what I do notice is that this 156 divided by 6, I think we can divide that. So how many 6s can go into 15? Well, that would be 2, because 3 will make it 18. That's too much. So 6 times 2 will give me 12. 15 minus 12 will give me 3. Bring down the 6. I got 36. So how many groups of 6s can go into 36? Well, that would be 6. And then I can just bring down my unknown over 15. So now I don't have to deal with larger numbers. Now, if you're thinking about taking your GED or your ASVAB or your Accuplacer, especially the ASVAB and the Accuplacer in some states, you're not allowed to use a calculator. So you're going to have to do a lot of this manually. But if I notice, instead of me multiplying and getting a larger number, let's see if I can reduce it here. Because earlier, 3/8, that's the lowest it can go. So I wasn't going to be able to do that division. But now, this is a one-step equation. We want to solve for the x. So x over 15, that means division. So I have to do its inverse. And its inverse is multiplication. And what would I multiply on both sides? Whatever the denominator is, which is 15. So 15 divided by 15, that gives me 1. Okay? Because if I think of it, it's really going to be 15x over 15. So 15 divided by 15, that gives me 1x, or just simply x. Okay, so that's where this x came from. So now you got your 15 times 26. All right, so here's my 15, here's my 26, and we're going to multiply. So 6 and 5, that gives me 30. Carry my 3. 6 and 1, that's 6, plus 3, that's 9. 2 and 5, that's 10, and that's going underneath the 10 spot, not the ones. Carry the 1. So 2 times 1 is 2, plus 1 is 3. So you have 390. So your x is going to equal 390. But what does that mean? Well, go back to the question. And it asks at the same rate, which is your equals, how far does it travel on 15 gallons? So how far is 390 miles? Okay. So if you know how to cross multiply, if you know your multiplication, okay, so you can identify to see if you can reduce, okay, fractions before you cross multiply, you can do that, okay? Those are going to be the essential when you're dealing with ratios and when you're dealing with proportions. All right, okay? If you have any questions on these or if you want to see more practice problems with these, please do not hesitate because if you click the link in my bio, you'll actually see a lot of math resources that I have to help you on your quest to understand ratio, proportions, and percents, and it's called Algebra at Your Pace. Okay, so now let's take a look at the next part. So as we said, this was supposed to be ratio, proportions, and percents. So now we're looking at percentage. And when people say, hey, when are we going to do this in real life? This is a real life situation. If you have gone shopping and there has always been a sale, especially Black Friday sales, okay, or any kind of holiday sales, this is exactly what you're doing. So we have a jacket, originally cost $84. It's discounted by 25%. What is the sales price? Now, this is what I normally tell a lot of my students. Do not trust to see what the label tells you, because sometimes they mark things up and make it seem like you're getting a sale. All right. So if we have a jacket that's $84, and here's the thing, when you're discounting by 25%, that means 25% is coming off the $84. But guess what? What amount or what percent remains on? It's going to be 75%. Now, this is one way that a lot of people are probably told how to do this problem. They're saying, okay, well, we have 84 and we're going to take 25% from it. So 25% translated into a decimal is 0.25. Okay, so now let's do our multiplication. 5 and 4, that's 20, carry the 2. 5 and 8, that's 40, plus the 2 is 42. Now 2 and 4, that's 8, that's going underneath the 2. And 2 and 8 is 16. And since we're multiplying, we're going to add these two numbers. So I have my first digit, which is a 0. 8 and 2, that's a 0. Carry the 1. 4 and 6, that's 10, plus 1, that's 11, carry the 1, and 1 plus the 1 carried is a 2. Now, the 84 doesn't have any decimal points, but the 2500ths has 2 decimal points. So when you're multiplying with the decimal point, that means you're going to add your decimal points together so you can figure out how many decimal points you should have in your answer, which this will give me 2, so that means I move it over 1, 2. So I'm looking at 21, basically $21. Now, we're not done yet, okay? This is the amount of money that's coming off of the $84. So that means we're going to have to take our 84 and minus the 21 for us to figure out what the sales price is. So 4 minus 1, that gives me 3. And 8 minus 2, that gives me 6. So of course, this is before taxes. So that means the cost of that jacket is going to be $63. Again, this is one way of doing it. And if you're like 25 plus in age, 25 and up, we probably learned it this way. But there's another way. So if you, which we do, have the cost of the original jacket, which is $84, and they're discounting, so that means they're taking away 25%. We're not going to divide, but if 25% is coming off, that means 75% still remains on to that jacket. And 75% as a decimal is 75 hundredths. So now we multiply. Okay, 5 and 4, that gives me 0, carry the 2. 5 and 8, that's 40, plus the 2 is 42. But this time we have 7 and 4, that gives me 8, carry the 2. And then 7 and 8, that's 56, plus 2. Oops, I was thinking 56. So we have 58. We're going to add these two together. So again, this has 0 decimal places. This has 2 decimal places. So that means our answer needs to have 2 decimal places. So let's take a look. Bring our 0 down. 2 and 8, that's 10. Carry the 1. 4 and 8, that's 12 plus the 1 gives us 13. Add the 1 to the 5 plus 1 gives us 6. And then we move it over 1, 2 decimal places. What do you notice? You get the same answer. Okay, so now you don't have to do the multiplication, then go back to the original amount and subtract. If 25% is coming off, that means 75% is staying on. And if you're asking, well, where did the 75 come from? Everything that we're dealing with percentage is dealing from 100%. So if I'm taking 25%, that's going to give me 75%. So if 25% is being taken from the full value of any of the 100%, that means you have 75% remaining. And that is the amount of percentage that remains on the jacket. Yeah. All right. So you have choices. I like to give you guys choices so you can see where all this is coming from. All right, so we definitely have a couple more, but if you'd like to see more practice like this, especially if you're taking the ASVAB, I have the AVIS math practice, but definitely, go ahead, follow me here, okay? If you want to like and you want to subscribe, that'll be wonderful so you can see when I have new videos coming out. All right, so enough of that plug. Let's go with the next one. Okay, so we're keeping with our percentage theme. Okay, so after a 20% discount, okay, after it, a 20% discount, a laptop costs $640. What was the original price? So we're kind of working in reverse here. Okay, we're working in reverse. So the 20% discount is gone. So that means we have how much left over? So out of 100%, okay, after the 20% is gone, that means there's 80% left over. Now, what is 80% as a decimal? We have our 0.80. But this time we want to know what was the original price. So think about what we did earlier. Sorry, I have to flip. Okay, think about what we did earlier when we were taking the discounts away. We figured out what the difference was, and then what did we do? We multiplied that percent as a decimal by its original cost. So that means we had to do multiplication, right? To figure out what that sales price is. But this time, we don't know what the original cost is, but we're doing the same operation. We're still going to multiply. Okay, so we don't know what the original price is. So original price, that's going to be my X. So since I don't know what the original price is, I'm going to multiply by X. But we said that the cost, which is equal to 640. Okay, so now we want to get X by itself. So what do? We do the inverse of multiplication, which is division. Okay, this is how we set it up. So basically not negative. So since we're dividing, they're going to equal to 1, so that gives us our X. But I know back in the day, they always say you don't want to divide by a decimal. So that means I need to move this decimal place over 2 places to the right in order for me to do the division. So it's going to look like this. So if I move it over 2 places to the right, that means this is going to be 80. But it's not going to be 80 divided by 640. How many places I moved to the right in the divisor, I have to do the same in the dividend. So I have to add a couple zeros. So for 80, how many 80s can go into 64? None. But how many 80s can go into 640? That will be 8. Because if you took away those zeros, you would have 8 and 64. So 64 divided by 8 is 8. And now we have these 2 extra zeros that we need to apply. 1, 2. So that's telling me that X is equal to 800. What does that mean? That means this was the original price of that laptop before the 20% discount. Okay. So since they said after the 20%, that means we had to pull the 20% out. What was left is 80%. So in order for us to figure the original price when they give us the sale price is take that percentage, multiply by X, okay? That means I have to divide both sides by 0.80 or 80 hundredths, okay? And then you'll get your division, which you have your answer of 800. All right? So one more, because One other thing that you'll see that I added to the percentages is this formula here, okay? This is when you're increasing or decreasing percentage. So what we do is we take the new minus the old and then divide it by the old and then multiply it by 100. So let me show you what I'm talking about. So a worker's hourly wage increases from $18.50 to $21.09. Okay. What is the percent increase in the worker's hourly wage? Okay. So if you want to figure out how much of an increase you got in your, because sometimes we get raises, sometimes we increase, maybe we want to be a manager and we get so caught up with like, oh man, I'm going to get like an extra blank and I'm going to be a new person. But then you have to ask yourself, is that increase really going to be worth it? Gotta know your worth, people. Gotta know your worth. So this is how you calculate it. So we know that we're going to use the formula. I like to use the new minus the old. Okay, and I'm talking about the values. Divide that by your old. And since we want to know what is the percent increase, that's why we're multiplying it by 100. Because we're going to change that decimal into a percent. So the new value or the new price is going to be our $21.09 minus the old, which was $18.50. And I know some people probably have done the absolute values because they always should have this number be positive. So some people may have do like old minus the new, and then you divide it by the old, but you were doing it with the absolute value. I just like to go with new minus old divided by old. Just I know I'm using the old twice. And then whatever we get from that fraction, we're going to multiply it by 100 to change it into a percent. So let's do some subtraction. So $21.09 minus $18.50. So that's going to be $2.59. And we're going to divide that by our $18.50. Now, when you divide that, you're going to get 0.14, okay, or 1400ths. But remember the last part. What do we have to do to change this from a decimal to a percent? Some of us may remember you can move it 2 places to the right, or you can multiply it by 100. All right? Either way, you're going to get the same result, which is 14%. So you got, or this person got a 14% increase from their old wage to their new wage. Okay, so to remember this whole value, your new minus your old divided by old times 100. Okay, if you can't remember the times 100, all you have to do is move from your decimal place 2 times. Why? Because 100 has 2 zeros. You're doing 2 different places. Okay. All right. So that's our ratio, proportions, and percentages. As I said before, if you need some more extra practice with this, you can look at the link in my bio, which will give you access to the Algebra at Your Pace series. It's a 10-book series, which will help you through anything that you need for the GED, maybe even some algebra review, also the Accuplacer, the TEAS test, the HESI test, so you can be better prepared for those exams. Now, if you don't come live with me every Saturday, I will be here next Saturday doing order of operations. That's what we're going to be doing. But also be on the lookout for my new little mini series I'm going to try out going back to basics. So really hitting home on how to add, subtract, multiply, and divide integers, basically looking at fractions, decimals, absolute values, exponents, as well as order of operations. So you can feel confident with those basic skills. All right. So if we can build up, and like I say, it's almost like a tree. So welcome to the tree, the learning tree by Audrey. So we need to get all of our foundations nice and strong, especially multiplication. If you can get multiplication down, especially up to the 12 times table, you're going to be able to effortlessly do these concepts, which will build up your foundation. So then you'll build up your confidence with algebra, and then you can actually branch out with more confidence. So now, if you ever go into calculus, you're not freaking out because the part that a lot of teachers will always say, if the kids understand the algebra, I can teach the calculus, I can teach the statistics. But if you're not strong with your algebra, it's going to be really hard for you to basically solidify and understand the other different branches of mathematics. All right. So I'm here to help you build up your foundation, help you build up your confidence. So if you have any questions, go ahead and message me and we can take it from there. All right. Well, thank you so much for stopping in. I will see you next Saturday at 1 p.m. Eastern Standard Time as I break down the next concept, which is going to be order of operations, so we can get a better understanding, improve our grades, and then be able to excel. Remember, these lives, there is no judgment whatsoever, just nothing but support. All right, everyone. So have a good one, and I'll see you next time. Take care.